Alright chat, so we're gonna be trying to add, I have this resource pack that I made with the help of a couple of people. It can actually port a post, this is a post shader. It's like not in the world at all. It's just a post shader. And rotation doesn't work yet, so that's why I'm gonna try to implement in this video. Rotation does not work. See, I have to align my camera for it to actually, like, if as soon as I move, it's like, oh shit, it doesn't actually implement rotation. So what is happening? Do you see that corner of my screen? There are a couple of pixels that are constantly changing whenever I change my input. Like, you can see a couple pixels moving when I move my mouse, and when I move my position, those pixels are moving as well. So what's happening is that black rectangle is actually somewhere in the world, but it gets projected to the corner of my screen. And then the texture on that rectangle is those pixel values. And the pixel values are my camera rotation and my position. I can show you. This is the vertex shader, which transforms the positions to a corner of my screen. And then we pass out the position of the camera to the fragment shader, which are the pixels. See, and what the colors are, like how did I convert the numbers to the colors, right? Because it's like numbers aren't colors. How do you put a number in a color? So what thanks to this guy, he actually helped me a ton in this thing. And also there was another guy that was like what's his name? This guy. This guy, Godlander. He's actually W guy. His pack also kind of put me in the right direction. Alright, so what I was trying to say was, how do we convert? The thing is, what? The thing is, to get position data and rotation data, we can only access that in the core shaders, which are like physical in the world. And the post shaders do not have any sort of data like this. All the post shaders can do is read the whole display. That's all that they can do. It cannot. They don't understand what's in the world. It's like it's reading the screen as a whole. So what it does is the core shader writes it to the corner of the screen, a bunch of numbers as colors, and then the post shader can read those values and convert them back to numbers and do some shit with that. In this case, which is a ray tracer, that the ray origin is my camera position. Well, I had to do some inverting stuff because the position isn't actually the world position. It's a position relative to the marker in the world. In this case, the marker is a mud block. There's a mud block somewhere in the world. If I turn off the pack, this is the mud block. It's centered at 0, 0 so that the coordinate system aligns. Let's turn that back on. And also uses the fabulous. That's how I get the post shaders running. Because in Minecraft, right, to get a post shader running constantly, you can like spectate a creeper. They have a shader that runs. I can replace this shader. I could also summon a Enderman. They have their own post shader, which in this case inverts, but I could change that, right? Also, some weird shit happens when I put other data in the corner of the screen, in this case the black Enderman. It's yeah, it makes sense, but at the same time. Also, spiders, they have their own shader, which in my opinion is the coolest one, that you can edit, right? But we want a shader that we can use at all times, and a shader that actually supports that is transparency. See, transparency is a post shader that runs all the time. Transparency actually runs all the time on the fabulous graphics mode. We can actually edit the transparency by adding a buffer called test, and then we do our ray tracing in there. Alright, so like how do we encode the numbers to colors? So what a number is, right? It's 32-bit floating point value. Right? So it's like 32 ones and zeros, right? And what a color is, it's a vec4, which is just 4 individual numbers from 0 to 1. And when you pass a buffer, like let's say a core buffer, like when you pass a buffer in Minecraft, they only pass 8-bit color channels. So each vec4 is actually 8 bits. It is 0 to 1, but it is only 8-bit in each channel. And the channels are red, green, blue, and alpha. 8-bit RGBA buffer. We can store 4 values per pixel, 4 8-bit values. And what are 4 8-bit values? They're 32-bit. So this is our R channel, this is our G, this is our B, this is our A. They each have 8 bits, and it actually lines up perfectly with one number, one 32-bit floating point number. 32-bit floating point. And let's say we want to port the position, right? That's a vec3. We can spread that out to 3 pixels. So we have position.x is a pixel, and position.y, position.z is also another pixel, and they all get stored in the RGBA buffer, right? So this is how I actually do it. I made this function that converts a float to a vec4 and spreads the bits out in the channels, each channel. So what it does, it first converts the float to like the bits, it converts it to an integer, but it doesn't actually convert it to an integer. It just turns it into a bit version of the floating point. So you don't lose anything. It's still floating point. It's just read as an integer. And what we do, we just bit shift, mask it, store it in the red channel. This is the red channel, green channel, blue channel, alpha channel, and divide by 255 because at the end of the day, colors are 0 to 1, not 0 to 255. And then we just encode view matrix and pixel coordinates, position coordinates. So in this case, this is testing. Like else, this is the regular shader. So like regular item shaders. And in this case, if our texture is that mud block with the custom texture, then we do the special case, which is this shit. So as you can see, it's a for loop because I'm not gonna encode every single number. So what it does is plotting a pixel actually tests if the frag coordinate, like the pixel coordinate, is the coordinate we want to plot the number on. So in this case, we plot position.x on 16.0, position.y on 17.0, position.z on 18.0. 16, 17, and 18.0, you can see it down here changing. It's very small. It's a pixel big. You can see it when I move my camera position. It's changing a lot. So then the post shader can actually read that information. There's actually channels to float, a decode function, which actually left shifts and adds to unpack the number from a float. And then this actually uses the texel fetch function, which reads like the whole texture, which in this case is the game. like this whole texture, and it reads the bottom left corner, each pixel. In this case, pixel 16, 17, 18. Put that in the position vector, pass that out. Then in the actual fragment shader, we in the position vector, and then um, we use it. This is just a ray tracer, it has nothing to do with the game. And the ray tracer in this case, what I did was overlay it with Minecraft. Like, it doesn't have to be overlaid. Like, if we just always display our shader, it's gonna be like this. I also put a gray and white background indicating that it's transparent. But you can't actually see transparent. We don't have transparent monitors in real life. Like, that makes no sense. So you can't actually see the alpha values. But just trust that it's transparent. Like, trust me, bro. And yeah, so this is our shader. But we want to blend it, right? So we can use mix, the mix function, which mixes the Minecraft version and our version based on a value. And what is this value? We can just use our alpha channel, see, to blend them properly. You can actually do like 1 minus the alpha channel, which will blend everything that is transparent. As you can see, it gives a very weird effect, but that's not what we want at all. You can actually multiply by 0.5, make it slightly transparent. You can do a whole lot of things. Now the sphere is slightly transparent, as you can see. But yeah, we just want to lerp or mix by that. So now that we're all caught up, let's try to implement, because I don't want just the position, I'm also porting the model view matrix, which is a matrix that should have the view data. And it's 4 components, so I'm kind of confused on that, since in my shader, the ray direction is 3 components. Here, it's just normalized UV, and UV is the texture coordinates and -1 in the z-axis. And as you can see in the structure for my ray, a direction is a vec3, not a vec4. So I guess, I don't know what I'm gonna do. In Godlander's thing, he only ported a 3x3 matrix for the view matrix. As you can see here, it says mat 3, not mat 4. Which should have been smart, because I have no idea what the 4th component does, because we live in a 3-dimensional space. Like, what the fuck is a 4th component of what? Like, the fucking alien axis? Like, I don't fucking know. So, I'm confused on that. So, I'm gonna still port all the 4 components. Something weird is that I actually couldn't use for loops when decoding it. I could when encoding it here. Here's encoding it. It uses for loops, it works fine. But look, as soon as I implement for loops in that, watch, crashes. Crashes. Just crashes. I don't know what the fuck happened. Just fucking crashes. And if we look in the log, Jesus Christ. We look in the log, implicit cast back to I have it. Oh, whoops. Never mind. Nah, I was being silly. Okay, wait, that wasn't what I was trying to. Ignore that, chat. Ignore chat. That. Oh! Wait. It works? Wait, it wasn't supposed to work. Wait, it doesn't work. Look. The sphere's gone. God knows why. Oh, now the sphere is actually gone. But what happened? Goodness gracious. Why is the sphere gone? I mean, where the fuck did the sphere go, bro? Oh, I'm not using Fabulous. Oh, for loops do work. Oh, my bad, I was just yapping. I don't know, it didn't work. Like, you can see the Discord chats. Here. And even he said it could be because I'm indexing. Because before I didn't have it return anything. It was a void function that just sets the value. But that didn't work, so I just set it to this, which is mvmap equals. But apparently that works. It literally made the whole screen black like a couple hours ago. But nah, this works perfectly. Okay, then let's just decode it normally, like a normal human. I'll just do that. And then this is I plus 4, I plus 8, I plus 12, realign all that shit. Sorry if I can't explain it well. Actually, I'm not sorry, I'm just bad at explaining. Wait, that should work. Oh, and then we have to change the channels of that. Does that work? Yeah, see? See? What did I say? Could it be because... See, look, if I only enable one, like, it's so fucking weird. Only enabling one works. But as soon as I enable two, shit turns black. It's because I'm using the same variable twice. Should I use J? J plus 4? IJ? Look, I don't know, bro. See? I don't know. I don't know why this happens. Why does it just turn black? Is there something in the console? Oh, yeah, there is. There is. Look, you see that? It's just ever growing. Invalid energy. Program object is not successfully linked or is not a program object. Severity equals high. See, what the fuck does that mean? Like, what does that mean? I don't speak. I'm not a computer, bro. But as soon as I only enable... It just magically works. Wow. I'm gonna kill myself. Could it be because... when I edit like that? Is that what it is? Nope. That's so... See, it's a random shit that I don't even understand, though. You couldn't... I'm just gonna... Fuck that. And just do 16 values manually. See, I even did it here. Don't fucking ask me why I can't use for loops. The screen turns black. So I'm just gonna insert 16 values manually, like a sane person. I'm normal, chat. Okay, I'm normal. I promise I'm normal. I promise I'm normal. If this turns black, I'm gonna kill my... Let's just test it without changing these too much. Just make sure we can actually write to every single part of the matrix. Yes, we can. So why don't the for loops work? Don't even try asking me. One, two, three. Okay, we just have to change every number here. Then 7, 8, 9, 10, 11, 12, 13, 14, 15. This should work. Yeah. Why does it work? I don't know. Am I insane? Yes, I am. Wait, we could just do this, right? That should work. Yeah. We can actually delete this. And remove RGBA. What? Bro, I feel like I'm insane. Like, why did I put .rgba? Like, what the fuck was that for? Like, it's already RGBA. I'm not swizzling shit. Like, okay, this should work. And it writes it to MVMat. So we init the MVMat. And then do we just multiply that with this? Like, times MVMat. Watch it not work because it's 3 components. What did I say? What if we have a 4 component vector? Like this. Vec 4 normalize UV. And then have like 1.0 times the MVMat and make the whole thing .rgb. .rgb. That could work. If not, then we have to only isolate the vectors that we want. Yeah, nope, it doesn't work. Where did it go? Do not ask me. Our fucking thing disappeared. Oh, this is gonna be a pain in my asshole. So we have to somehow make the model view map 3x3. Convert a 4x4. Turn 4x4 2x4. Does that work? Can I just do that? Does that just work? Just redo that? Well, it works, but not like that. You guys think it's inverted? Just negative. For some fucking reason. Like, I don't even know what I'm doing there. How do we make a fucking matrix work, bro? We have to think about this. What if we did the multiplication inside the normalize function? Why'd I expect it to work? What the sigma? I don't even know if my shitty ray tracer supports rotating at all. Like, let's just multiply it with a... How do we make a matrix? How do we even write a matrix in the first place? Where's Godlander's thing? Please, when I need him, he's not here. Mat 3. Oh, it's just like that with commas. Alright, I'll just do that then. So it's... I'm gonna make an identity matrix. Like that. If that doesn't work, then I'm just gonna kill myself. Good news. I mean, bad news, it doesn't work. But good news, I'm gonna kill myself. Oh, great, doesn't even work normally. What have we done? Am I even using... Oh, like, shit like that always happens, bro. Okay, this should work. Yeah. So what if it was that, let's say. Um, uh, um, um, that was scary. And the huh? 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 Wait, what the fuck? It actually just, it just, it just works? It just fucking, bro, I love you, God. God, thank you. Thank you. You literally just multiply it by the view matrix and it just magically works. What if it was negative? Bro, I never had a ray tracer where I could rotate stuff. Like, I never cared. Because it was like rotation matrices and shit. It's like, ew. Yeah, it fucking worked. Now, the next step is depth buffers. Yeah. And so far, I think that we can actually get a depth buffer. Yeah, there is a diffuse depth sampler. But when I tried it, it was just all black. Alright guys, thanks for watching. I'm gonna debug this some more later.